robots are these incredibly vicious monsters. Yeah? Each of these are the industrial robots that you use for welding car bodies. So they're like really the blue collar stock of the 21st century. There's something like 3 million industrial robots working on this planet right now. And it's a complete parallel universe. It's like we don't see them, they're always tucked away in factories. But when you take them out of a factory, it's a big problem, because in the factory you get everything you need. On the floor you have media supply, and media supply means you have cooling water, heating water, power, welding gas, data lines, everything. It's all on the floor. You can open up the floor anywhere. You can put your robot onto a very solid concrete floor. You have to bolt it down, because these guys, they weigh 1.5 tons and have 24 kilowatts of installed engine power, which means these 1.5 tons move very quickly. And if somebody presses the emergency stop, the brakes just hit in, and the robot, if it's not really properly bolted down, will just rip itself out of the floor and destroy itself. So you have to secure these things in a really insane way. And if you bring them on Trafalgar Square, there's flagstones which are like 2 by 1 meters. Each one costs 6,000 pounds to replace if you damage it. And they really don't like the idea that you put holes into it, like, and big German screws, and just bolt down robots. So essentially what you have to do, not only do you have to bring all the infrastructure, all the power, all the wiring, all the data, all the media supply, the cooling for the LEDs, blah, 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 because you're not in a factory, you also have to build a factory floor in order to be able to lock down the robots. And basically the factory floor is these 3 sea cargo container-sized slabs of concrete. Each one weighs 15 tons and has 2 and another 3 robots bolted on them. And then under this plinth, there's a massive amount of switching boards, cabinets, robot controllers, all these like crazy boxes full of technology. And another thing with robots is that they're really, we call them robots, but really and truly they're only arms, right? It's just a robotic arm. It's a limb. The robot can't move. The robot will have to be bolted down, and the robot doesn't even have a hand. So it's really a Captain Hook kind of situation. It's like Captain Hook without a hook, where the robot you buy or get ends here. So there's no hand. There's nothing. And also the robot doesn't really know how to move. You can't tell the robot, move up. You have to write a set of instructions that tells the robot to move on the set axis into positive by a certain amount. So there's no immediate way to even control a robot. It's a very tricky business. And this idea we had that people could send half a tweet to the robots, and then the robots would paint their message in light, have these cameras around the plinth, record the light message, seemed quite straightforward, but then as you start getting into it, you realize that in order to send a tweet or a message, the alphabet you have to produce is quite significant. So we ended up with something like 92 letters, numbers, and special characters. You need a $sign, otherwise you're fucked. You need all kinds of things. So this is basically the BlackBerry keyboard as of 2010 became sort of the benchmark. But each of these letters needs to be turned into a robot program, and also into a robot program the robot can actually do. So you can't just tell the robot do Arial or do Universe or do Times New Roman, because that's not the way a robot thinks. A robot, you need to give the robot a path, a movement. So it's much more like calligraphy, or much more like drawing or like handwriting. It's not the idea. Like all the typefaces we use on computers, they all come from print. They all come, they're kind of stamps. But the robot can't stamp unless you build a stamp tool. If you want to draw light traces, they have to be paths. So we basically designed this entire alphabet, and basically the way it works is people were able to go to Outrace.com and just punch in a 70-character message like, please do not feed the robots. That message would be sent to the robots would write the message, and then a set of cameras would record the message, and these cameras were on long exposure. So basically, as the robot writes, the camera, the apertures open, and you basically capture this entire trace of light. Little bit like maybe you know the Picasso drawings he did for Time magazine, for the Time magazine cover, using a torch, where he's like topless, wearing these pants and got a torch and does all these kind of bullheads and stuff. It's that kind of principle. Also the effect you get if you do long exposure camera in a city at night, and you get these kind of traces from the, you know, red traces from the backlights of the cars. And on a tech level, the whole thing is a bit more complicating because you need a lot of cameras. So there's 36 5Ds around the plinth. This is all the cameras. And then you get the robots in the middle with the individual controllers. That's the C2s. Then you have an SPS system that synchronizes all the robots, that tells the robot controllers what to do. It basically says, robot 1, do the letter A. Robot 2, do the letter B. Robot, you know, and so on. And then the robots start doing their thing. And at the same time, the SPS is connected with the camera system and tells the camera system, robots are going to start working in 3, 2, 1, record, boom, and the cameras start recording. And when you take the frames from all of these cameras afterwards and assemble them, you get this thing called bullet view, and you know it from this old film called The Matrix. And in The Matrix, it was the first time they used lots of cameras around an object, and when people jump up, the camera seems to move around the person at a speed none of the arms you get for cinema productions could possibly move. So you get this kind of circular turntable effect called bullet view, and that's exactly what we did here. You assemble these frames and create bullet view. We had incredible people using Outrace. One of the first ones was Kate Moss. There was also obviously Bruce Sterling hitting the robots. A robot who is tired of London is tired of life, and there was it's a truism, and you know, many others. So we learned a great deal there because we generated within 48 hours something in the region of 3.5 million Facebook impressions, and this was back in the days when Facebook was for free. But it was insane. We you know, the service collapsed. Like really, like the hardware just broke because so many people tried to go on it. And it was the first attempt at actually connecting a robotic system to the internet and just let the public use it and take it.